guys, my name's Tyler. Today we're going to talk about confidence intervals, and I'm going to explain a little bit about what a confidence interval is. A confidence interval is basically what we use when we take a sample statistic and we want to be able to predict things about a population mean or population proportion. And so using the data, we can make an interval that we are a certain percent confident that the true population mean or proportion is contained inside that interval that we give. And now Luke is going to explain the different formulas that we use. Okay, first, if we're going to want to be able to solve for confidence intervals, we're going to have to understand what a t-star and a z-star are. Okay, so a t-star is typically used when you don't know the population standard deviation of perhaps a sample mean test. And a z-star is typically used whenever you use a proportion for a test, or if you're doing a mean test and you know the standard deviation of the population. First, we're going to talk about the t-star. The t-star looks like this, and it comes from on the normal curve, you draw a normal curve and here is mu. The t-star could be on either side, but let's pretend it's right here, and the t-star basically represents a certain number of standard deviations away, just like a z-score. And so that will represent that shaded portion right there. Okay, so if you got your calculator and you need to find your t-score, then all I have to do is start off by pressing menu, which will take you to the menu, and then 6, which says statistics, and then 5, which says distributions, and then 6, which says inverse t. Once you do that, it'll ask you for area and your degrees of freedom. And area is typically, you have to use it, you have to figure it out based on how much confidence you want in your confidence interval. Let's say if we want a 99% confidence interval, then your area is going to be, your 99% is going to be in the middle here, and your area under it has to be split in half on both sides of it. So if you have a 99% confidence interval, then located in this area right here has to be 0.005, because you have it on this side too. So you have 0.005 here, and you have a 99% in the middle, which you're representing. So for a 99% confidence interval, you would have an area of 0.005, and then your degrees of freedom is just your sample size n minus 1. So whatever size sample you use, you would just use n minus 1. And then you should get a t-score to be able to put inside your confidence interval formula. Getting your z-score is really similar. In fact, it's actually a little bit easier. Getting your z-score, it'll represent the same normal curve that we drew before with your mu, and your z-score basically just explains how many standard deviations away you want to be for your confidence interval. So in order to get your z-star, we're going to start off with menu again, and then go to 6 again for statistics, 5 again for distributions, and this time instead of 6, we're going to hit 3, which stands for inverse normal. And once you hit inverse normal, it'll ask you for your area again, which is just like we explained before, with how much percent confidence you want on both sides. So we'll put in 0.005 again for our 99% confidence interval. And it'll ask for mu and sigma, standard deviation, and they'll be preset to 0 and 1. Just leave those as 0 and 1 and press OK, and that'll give you your generic z-star for a 99% confidence interval, which would actually be negative 2.576 for 0.05 area. And that's how you find your t-star and your z-star on your calculator to put in those formulas.
For confidence intervals, there are a bunch of different situations that you can be given, and for these different situations you have to use different formulas. One of the situations is when you are given, or when you're asked to solve for the confidence interval of the mean of a population when the standard deviation of the population isn't known. and you have to use this formula. X bar plus or minus T star times the standard deviation of the sample all over the sample size of the sample. And you have to use the standard deviation of the sample size because the standard deviation is a given, and when that happens you have to use the t. You have to use a t-test. Next is the confidence interval you construct when you know the standard deviation of the population. Use this formula. X bar plus or minus Z star times the standard deviation of the population all over the square root of your sample size. And this is when you use the Z. It's called the Z confidence interval because you have to use the Z star value because the standard deviation is known. The next one that you're given is when you're given two means, and you have to construct a confidence interval about the difference between the two means. And this is when you use x bar 1 minus x bar 2 plus or minus T star times the square root of the standard deviation of the sample for x bar 1 squared all over the sample size of x bar 1 plus the standard deviation of the sample for x bar 2 squared all over the sample size of x bar 2. And then you still use the t-test statistic here because standard deviation of the population is not known. Next are when you're dealing with proportions and you have to find the confidence interval about the proportion of the population that does something. And this is when you use p hat plus or minus z star times the square root of p hat times 1 minus p hat all over n, which is the sample size. And then p hat is the proportion of the proportion of your sample size, because that's what p hat means. And then you have to you use z for everything with proportions. Next is when you're given a situation where you're supposed to solve for a confidence interval that is the difference between two proportions, p1 and p2. And then you have to use this formula, which is p1 minus p2 plus or minus z star times p hat 1 times 1 minus p hat 1 all over n1, which is sample size of the first group that you're solving for proportions, plus p hat 2 times 1 minus p hat 2 all over the sample size for the second group that you're using for the proportions. And you have to take that all under the square root. And then that's how you construct the confidence intervals. And then based on the situation you're given, you have to choose which formula to use to solve for your confidence interval.
So our condition check for this data is we need to check randomness, independence, and normality. We know that it's a random sample of 2,350 vaccine eligible people. We know that 10 times the sample is less than the population. And we know that the sample size times the p hat and sample size times 1 minus p hat are both greater than 10. Our p hat for this data is that the 978 people out of 2,350 that were sampled had gotten the vaccine. So our p hat is 0.416. A z star for a 99% confidence interval is inverse norm 0.00501. So our z star for this data is 2.576. The equation for a confidence interval for a one proportion test is p hat plus or minus z star times p hat times 1 minus p hat over n. So we plug this into the equation. 0.416 plus or minus 2.576 times the square root of 0.416 times 1 minus 0.416 over 2,350. And we get a confidence interval of 0.390 to 0.442.
The final step is interpreting the results of your confidence interval. There are two ways you can be asked to interpret the results. One is in context of the problem, and the other is what the confidence interval actually means in the long run. First, in context of the problem, we got the confidence interval of the lower bound, 0.390, and then the upper bound, 0.442 of the proportion. So the way we would interpret this is that we are 99% confident that the proportion of people who are eligible to receive vaccines, who receive the flu vaccine, lies in between the numbers 0.390 and 0.442. That's how you would interpret it in context of the problem. The other way you can be asked to interpret it is what this actually means in statistics. So the way you explain that is you say, if this procedure was, if a confidence interval similar to this one was constructed many different times, 99% of the confidence intervals constructed will contain the true proportion of people who are eligible for vaccines who received the flu vaccines. And that's kind of what this graph shows, is when you have a bunch of different confidence intervals on a number line, this is actually the true proportion of people who received vaccines who are eligible for it. And then this is the confidence intervals, and it shows how this is the middle of the confidence interval, which is the proportion of the sample, and then how it captures the true mean in all three of these. And that's just an example of, that would be 100%, but the idea is given.
Woogie, 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 woogie.